So I've gotten a few comments on some of the other videos that I posted on my Lyman Power feed for my Bridgeport milling machine, and thought I'd make a few comments about it. I've been using it for a while now. It is infinitely better than not having a power feed, period. But at the end of the day, it's a DC motor with brushes on a potentiometer to control speed, and consequently, the problem with that is that at low speed you have nearly no torque, and the fallout of that is that it's really easy to stall it when you're trying to do like slow creeping cuts. And we're going to give this a demonstration here. So we're going to flip this switch to dial. Oh, it was already on dial. Has 3 positions: fast or rapid traverse, stopped, and dial. If we switch it to dial, and please ignore the position of this, the little potentiometer was busted so that it doesn't line up in the right place. Then we have travel direction, so we're just going to put it this way. And we have a momentary switch here as well, which is jog, and it's supposed to have a light, but I couldn't find one of those switches with a light. So if we jog it, you can hear the thing, and it's kind of flying along pretty good. Does a good job. If I sit here now and I start turning this up, you can sort of hear it making a noise, but it's not moving. And then we can speed it up a little bit more. And you can kind of hear it down at the low end. It's arcing a lot, and it's making a lot of noise, and it's kind of like starting and stopping, and then kind of you get to about here, and it's capable of reliably transferring the table. But if I put a little bit of pressure on this, I can stall it before it jumps it out of drive. So that's the other thing, is that this has got a spring-loaded over-center device that allows it to jump out of drive if you get too much of a load. So we're going to give that a demonstration here. I'm going to turn the speed up like that, and I'm going to come over here and I'm going to stop the handle, and it jumped out of gear. So you can see that the lever did that. It jumped out into hand drive. We're going to turn that off. You can also put this down in stop mode, where it's engaged with the drive, with table as well. And my mill has a huge amount of backlash, guys, so very worn out, but does enough for what I need it to do. That's engaged so that you can't really move it back and forth. It just kind of sits there. And then you have drive, which is in the middle position. And if I do this, I'll give you an over center of kind of what it's looking like in there. Those are the drive gears. So there is stopped. Is that stopped? Yeah, that's stopped. So I lied before. It's actually not engaged at all. There is drive, and there is hand feed. I honestly couldn't tell you what the difference is between them. But what we're going to do here is we're going to kind of pull off the table, and then I'm going to kind of go over the wiring routing, because I got a question about that on one of my other videos. And we're also going to do some measurements on the drive gear. I suspect that when people get a hold of these, sometimes the gear on the actual shaft is missing. Got some questions about that. I'll try and answer them as best I can. But removing this thing is pretty easy. We're going to grab some tools, and we're just going to kind of pop it off and flip it up the other way, and go over a few things and make a few measurements. Now, before I move on to removing this thing, I did want to state one thing, that this thing has one feature that I think is just absolutely amazing, and that is it makes an excellent tool tray with a bunch of little pockets. You can stick stuff on there and it won't roll off or fall down into the T-slots. That's something that I do really think they did a good job on, was setting it up with a bench top on it. So In order to get this thing off, all we need to do is just loosen this one bolt here. It's pretty straightforward, and then we just kind of lift it up on one side. You can see that it's kind of flopping around, and we will go ahead and remove the nut here. I'm going to do this all one-handed. Truly show off. We'll just set those right over there now. And then this bad boy here just kind of lifts off. There we go. So here we have the underside of the Lyman Power feed, and we're going to kind of go over its operations. And we're also going to go ahead and pull some measurements from the main drive gear on the Acme screw that drives the table. Okay, so because both switches, main drive switches here, are double pull, double throw, as is the momentary, the entirety of the wiring is pretty much a rat's nest. And this, when I first got this, all the switches were smashed because it had a really hard life. The switches were smashed, and the actual handle itself was broken. I had to do a weld repair right there that I shamefully didn't do the greatest job on, but it's working for me just wonderfully. It was in a pretty sorry state, to be honest with you, and I think one of my other videos also shows the fact that I had to turn down the shaft under the brushes, and it has a little worm reduction gearbox in here and everything to get your speeds down. But if you look at this, the way that it's plumbed, we have 4 wires coming from the motor through this connector back into the switches. And if you already have, you know, your wiring in there, you're going to be okay. If you're missing it, this is going to be a real challenge to sort out. So I'm going to try and guide as best I can here, but there's no guarantee that this is going to fly for you. So the way that I've got this set up, I've got the motor wires coming in here to the close side to me on this double pull, double throw switch. The blue one comes over here, ties into one end. Red one ties into the middle. And then the black wire ties into the other side here. And what this is doing is this particular, this switch is your directional switch. So when you flip from one side to the other here, which is why it's mounted sideways, if you can see that, this is reversing your direction. So in this case, the blue wire coming from the motor is one way, the black wire coming from the motor is the other way, or the other ground, I guess you could say, and then the red is your live wire for the motor. And I'm honestly not entirely positive what the yellow wire is for. I would have to think about that a little bit. Next thing that we've got is the potentiometer is sitting inside this little circuit board. It has some stuff in there. Frankly, that wasn't broken, and I didn't feel like touching it, so there it sits. I had to straighten out a few things because it was bent and the shaft was messed up, which is why my switch doesn't align, but there it is. It has another set of 3 wires coming to it. You know, I'm thinking about it right now, and really good chance that the yellow wire is your slower speed and rotates the motor at a reduced voltage, now that I'm thinking about it, which explains, well, it doesn't entirely explain. That might be your ground for the lower speed. I'm honestly not sure, guys. Honestly, I don't have a wiring diagram, but you can just kind of see from the routing, and this is all working nicely. Once again, we have another dual pole, dual position throw, and then so the controller on this side runs partially through the backside of that DP-DT switch, which also has your main hot connections running through to it. So we have, oh yeah, okay, all right, sorry, my camera's probably moving all around. We have a ground wire soldered on to a ring at the base of this switch for the power, and then we have the part of the hot line runs through the center there, which makes sense. That's basically making the center of the directional switch hot, giving you power control. And then the other side of that power coming in runs through the back side of the fuse over here, and then that powers up everything else with both sides of the switches, the momentary switch in there. So that's always hot, and then that also powers the hot side of the speed control switch and the on-off for the controller. And so it's a wicked rat's nest. I'm gonna try and take I'm gonna stop this, and what I'm gonna do is I'm gonna try and spread the wires out as best I can so that someone could kind of follow how they're all hooked up, and hopefully that helps, because it's a bit of a mess. And unfortunately, if somebody went through and cut the switches off, or you don't have them, or somebody else removed them and never put them back, there's almost no way you're going to get this thing to go back together without seeing how the wires are all laid out. So I'll do this the best I can here, and hopefully that's a helpful thing. Real tough dealing with these obsolete pieces of equipment. Okay, I've kind of done my best here. It's still a bit of a muddled mess. So this wire here on the right, this is from the motor. This runs down here. We have a hot lead going to the center of your table directional switch. We have the blue wire coming to the one direction of the directional switch. We have the black wire coming to the other side of that switch. And then something that's important to note here is that we've got jumpers crisscrossing to the other side in each case, from where the power is connected in, or where the motor is connected in, to the inverse on the other side of the DP-DT switch. And then on the back side here, we have the hot wire coming in from the power source, and then the ground is just grounded to the casing at that point. So that's how that's wired up. And then on the back side here, we have the red wire running over to the potentiometer, hooked into the center of the hot line as well. So this wire here from the potentiometer is also wired in to the center over here on this side. There's two connections there, two discrete connections. That kind of covers that particular set of hookups. Then we have a momentary switch here, of which not all of the connections are hooked up. That's important to note here. And I followed exactly how all of this was hooked up on the unit. When I removed the old switches, I did them one at a time, and I installed the new switches so that there was no possibility of messing them all up, and this is how they were done. So right, wrong, or otherwise, this is currently working and in good shape. So we got and forgive the small size of this switch, this was the only one I was able to find. This is also I can't remember the designator for this switch, to be honest with you. I want to say it's a DP-DT with momentary on. So the way that this is hooked up, the yellow from the motor comes to one side of this switch. The blue from the potentiometer comes to the opposite corner on this switch. Power feeds to the center connector from the fuse on this switch. And then we have another power lead coming off right here, running to the back corner of the slow, fast, and off switch. Now this is also, this corner here, which hooks to the yellow on the motor, also runs to the center of this switch and then hooks to the yellow on the potentiometer, which has a jumper from this side to the other, and then also jumps back to forward. And then we also have a power line, sorry I'm jumping that around too much, powering up the center of this switch on the other side. So it's a real ratty kind of mess. But the important part to pick up on is that this right here is a hot line and runs around the back of this little fuse block and into the center right there. I think I've covered all of the way that the connections are made up. That's really the best I'm going to be able to do for this thing at this point. So what I'm going to do next is I'm going to go ahead and we'll grab our calipers. We'll do a tooth count. We'll measure the OD and the ID of this gear, and that should give, you know, hopefully somebody some help. So this is going to be pretty straightforward. We're going to mark one tooth right there. Oh, let me do it like this actually. We'll just pull that right off there. And I used high pressure gear grease in here when I put it together. There we go. We're going to say that this tooth here, oh, it's not, there we go. This tooth right here is our starting tooth, and we're just going to do a tooth count, which you can do in the video on your own if you want. But what we're going to do here is we're going to count these up. That was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 22, 23, 24 teeth. 24 teeth. It has an OD of 1.615, let's say 1.615 approximately. And then what we're also going to do is we're going to pull a root diameter on the teeth here, because I don't really have any way to measure the pressure angle or the pitch. So we're just going to do this, and that is 1.345, and that should be about the best that I can do for the gear itself. Again, I have no documentation, manuals, or information on these. It came with my machine, and I got it up and running so I could use it, and my gosh, it made life an awful lot easier for me, for sure, as soon as I did that. So we'll go ahead and get this back together again, give some closing commentary. Okay, a few closing thoughts on this that I thought I really needed to say. I don't actually think this is a particularly good unit, and I think that that's probably why they ended up going out of business and not still being around today. It came with my milling machine. It was the cheapest option to get a power feed going. I had to spend something like 15 bucks on switches and a fuse box and fiddle around with it, and up and going we are, and now I've got a power feed. So it's really hard to argue with that. Would I go out and buy one of these on eBay to put it on my mill? No, I'd buy something better. Honestly, the ultimate solution is the old, well, might not be the ultimate solution. Some of the modern servos are pretty good. I have no experience with those, but I do think that the manual gearbox drive that was offered originally by Bridgeport with these machines is a far superior solution, with its own little electric motor and then an actual gearbox with change gears to set your drive speeds, because they are guaranteed to be what you think they are, and it's going to do a really good job of giving you good feed power at low RPMs, which this is definitely has a detriment. And I think The more modern servo drives are probably better about that with decent torque at lower RPMs, but I can't speak for them. I can say that this isn't a particularly good solution. It works for me. I'm happy with what it's doing. It's a huge improvement over sitting there and spinning the handle manually, but it's by no means great. And I thought that needed to be said. So it's the best I can do on kind of going over this thing. Limitation of obsolete equipment, I'm afraid. You can see it's lived a really hard life. Most of the stuff is kind of gone off it, although the serial number is still perfectly legible. The rest of it's pretty, used and abused sort of thing. But there we go. Put the wrench back on my nice little tray here. And that'll be it for today.